10, I said the number of gallons of oil that leaks from the tank from 0 to 120 minutes.
That's the same.
All right, let's go through the ones we need for sure. So 1 and 2, the fundamental theorem, I went through those two with you yesterday. You guys understand that now. Has to go from a number to an expression, and it's only when I ask you to do the derivative of the integral. So you guys are good on that?
Was it 2x times x2
Yeah.
plus 1?
Mm-hmm.
Square.
So problem 3. I want the total area between x cubed minus 2x squared minus 15x and the x-axis. Okay, unless I tell you to sketch it, a picture isn't required, but it can certainly help. We first need to find out when this is equal to 0. So if you factor out an x, and this would factor into x minus 5, x plus 3. So it's going to hit the x-axis at 0, 5, and negative 3. If you remember, a cube, it's like a chair. So it looks like that. You could also pick in some more test points if you need to. Just plug in a number between those zeros to see if it's above or below. But I'm trying to find this area. If I just integrate from negative 3 to 5, what it'll do is count this as a positive, this as a negative, and subtract them. That's not the total area that's enclosed. So we have to break it up. We're going to have to go from negative 3 to 0, and from 0 to 5. Between negative 3 and 0, the function is above the x-axis, so it's already positive, so we're just going to keep it like normal. Between 0 and 5, it is below, so we have to do the opposite. So distribute a negative through there to make it positive. What?
I'm sorry.
Did you say that's not thunder?
I was thinking it was loud.
Sometimes when you go outside at the baseball field, you think it's thunder, but it's really just the world's biggest truck driving on the road.
Oh, that's helpful. So antiderivative of x cubed would be 1/4 x to the 4th minus antiderivative of 2x squared would be 2/3 x cubed minus the antiderivative of 15x would be 15/2 x squared from negative 3 to 0. Okay, same thing over here, just your signs are opposite. From 0 to 5. I didn't know leave myself enough room there, but are you guys okay to that point? So now it is a matter of plugging things in to evaluate. So if I put in 0, we get 0. Minus, if you put in negative 3, negative 3 to the 4th is 81 over 4. Negative 2/3, negative 3 cubed, that would be a negative 27, so that gives me plus 18. Minus 3 squared is 9, times 15 would be 135 over 2. And over here, if I put in my 5, I get negative 625 over 4 plus 125 times 2/3, so 250 over 3 plus 15 times 25, 375 over 2 minus 0. And then when you evaluate that, you get the 863 over 6.
So if it goes from a negative to a positive and we're looking at area, we have to use the apps. We have to do like this way.
Mm-hmm.
Okay, that's where I.
Yep.
That's where I did that.
Is that one okay? All right. So number 5. We have the integral from 0. I did pi over 2, right?
Mm-hmm.
cosine x dx. Keep in mind, when you see that sine squared, that means sine of x squared cosine x dx. The biggest issue I've seen, we know we can't do a product rule in reverse, so substitution. What I'm seeing is that people are trying to put the square with it. So when we talked about u, we said it was the inside. You don't want to make it the whole thing. And you'll know if you do too much, because if I do the derivative of this, the 2 comes down, inside stays the same, subtract 1 from the power, times the derivative of the inside. Do I need all of that? No. So I have made more work for myself. So instead, just let your u be the inside of the parenthesis, the sine x. Then du, derivative of sine, is cosine x dx. You need the dx with it. So when I see that's going to become a u, cosine x dx becomes my du. And that took care of all my x's. Most of us are changing the limits here. You don't have to, but if you don't, you have to replace the u with the sine x at the end. If you want to go ahead and change them, you put a 0 in for your x, sine of 0 is 0. Put a pi over 2 in for x, sine of pi over 2 is 1. Then we have sine x squared, so it would become u squared, and all that green is just my du. So the antiderivative of u squared is 1/3 u cubed, from 0 to 1. So 1 cubed is 1, minus 0 cubed is 0, and 1/3 times 1 is 1/3. Questions on that? Number 7. So we're integrating from 1 to 2. I have 2x cubed for x to the 4th minus 5 squared dx. I have changes written on my original one with pencil, and I wanted to make sure I actually changed them before I printed it. So again, we have x's on top and bottom. We can't just simplify this because we have more than one term on the bottom. So we have to go with a substitution. You want your u to be the inside. So you're looking, if you have a parenthesis or something, that's your inside. So my u is going to be x to the 4th minus 5. So du, derivative of x to the 4th is 4x cubed, and when you do that derivative, it gets a dx. Alright, look at what we have. We want the x to the 4th minus 5. I want the x cubed dx, but do I need a 4? No, I need 2. So a couple different ways you could do it. I think most of you just divide it over, or divided by 2 on each side, so 1/2 du would equal the 2x cubed dx. So then that would replace all of this. If you didn't like doing that, you could have factored the 2 all the way out and then divided the 4, and you get there at the end. These are my x values. So if I plug them in to find u, if x is 1, 1 to the 4th minus 5 is negative 4. If x is 2, 2 to the 4th is 16 minus 5 is 11.
You only have to do that if you're not plugging that.
Correct. So then I have my u squared on the bottom, so I'll write that as u to the negative 2. All the green stuff gets replaced with my 1/2 du. So I have the integral of 1/2 u to the negative 2 du. So antiderivative, add 1 to the power, so we need a reciprocal in front. From negative 4 to 11. So we have negative 1/2. If you put in 11, that's 1 over 11. Minus, if you put in negative 4, that's a negative 1/4. Plus, so that's 15 over 44. If you get your common denominator, multiplies the negative 15 over 8. Any questions?
So whenever you plug in the two numbers to the interval, you don't need a 15.
Right, but if you didn't change these limits, if you had kept them as 1 and 2, then after you do your antiderivative, you change your u back to the x to the fourth minus 5. So really, two different ways you can get to the answer from there. Other questions? Number 8. Here's the interval. X cubed minus 2 radical x over x dx. This one, do we have to do substitution? No. There's only one term on the denominator, so we can simplify it. When you do that, you subtract exponents, so that's x squared minus 2. This is x to the 1/2. 1/2 minus 1 is negative 1/2 dx. So antiderivative, add 1 to the power, reciprocal in front. Here, if I add 1, that's a positive 1/2, reciprocal is 2, so that's a 4. And since I don't have limits to plug in, we put plus CS. Number 11. I'm asking you to draw a sketch. So if I say draw a sketch, you have to draw a sketch. Okay? It doesn't have to be great. But I want a sketch to sketch the region enclosed by the curves and find its area. So we'll need our picture. If you want, you can go ahead and find the intersection points. I need to know when 6 minus x squared is equal to x squared minus 12. Out of my 12, I get 18 equals 2x squared. So x squared is 9. Square root plus or minus, so x is plus or minus 3 when we meet. Right. So if you were graphing 6 minus x squared, you could just plug in some points. If x is 0, what do you get out? 6. If x is 1,
5,
if x is 2,
3,
2 squared is 4, 6 minus 4 is 2. If x is 3,
Negative 3.
yeah, that one.
and over here you're getting the
Same
same
thing.
things. Okay, so here's that one, and we only need to look between positive and negative 3, right? Because we already found those intersections. So your graph doesn't have to be great, just close. The other one, x squared minus 12, just a parabola shifted down 12. If you put in 0, you get out negative 12. We already know positive and negative 3, they're the same. So we're getting something like that. 2 semicircles touching. I just want the area of this. So we just have to integrate from where to where? Area is just top minus bottom. Right, so the top one is my green one, so that's 6 minus x squared. The bottom is the red, which was x squared minus 12. If you've set this up wrong, how will you catch it later?
You have a negative like I have in my problem.
It'll turn out to be negative.
Even though I plugged in this.
All you have to do. Minus.
Because you went between them.
Why did I square it? Interesting.
Oh, you were doing volume.
I guess.
Oh, I just split it up.
So if we combine like terms, we get 18 minus 2x squared dx. Antiderivative of 18 is 18x minus the antiderivative of 2x squared, 2/3 x cubed, negative 3 to 3. So then when you evaluate, you plug in 3, 18 times 3 is 54, minus 18, minus if you put in negative 3, negative 54, plus 18, so we get 108 minus 36, so 72.
I'm not gonna lie, I got so confused on this for like 30 minutes. I about looked up the area of an oval and just,
Instead of just realizing you could integrate.
yeah, well, I eventually just integrated, but I split it up and I basically did that, but just split the integral.
Did the two and then subtracted them afterwards.
An actual real reenactment of me doing this 3 hours ago was, did I do those wrong? And I looked at the one with the pie and the squares, and I looked back and I went, no, I did those right. No, I didn't.
So area between curves is just like when we're integrating and finding the area between the axes. If it's just between the axis and the curve, it's just a straight integral. If it's between two curves, you have to integrate top minus bottom. Then problem 12, we are again finding area. So I want to sketch the region enclosed by the curves. X equals y cubed plus 1 and x equals y plus 1 and find its area. So if you want, we could go ahead and find our intersection points. Is this the one that we would want to do in terms of x or y? Probably y. We could just set these equal to one another. If you subtract your y, subtract your 1, you get y cubed equals y. The greatest common factor is y. You get 0 plus and minus 1. So we're looking when y is 0, 1, and negative 1. So if we get these graphs, if y is 0, 0 cubed plus 1 is 1. So that means when x is 1, y is 0. If y is 1, you get 2. If y is negative 1, your x turns out to be 0. Okay, and we should know a little bit when you're seeing cubes. If you were solving this, it would be a cube root, so it's like a sideways chair. So it's kind of curved. This one, they're both to the first power. So what's this graph?
Linear.
It's a line, yeah. If you didn't like the way it was written, you could certainly solve for and rewrite it. You know, y equals x minus 1. It's just line y-intercept of negative 1, slope of 1. So we're looking at that. So we are finding these. Okay, so you have to split it up because the top and bottom curve changes. So we're going to go from negative 1 to 0 and from 0 to 1. Alright, when we did it in terms of y, we did right minus left. So you want the bigger minus the smaller. And if you mix it up, you'll know because you'll get a negative. And we have to do the opposite value of it. So the curve on the right was my red one. So that was my y cubed plus 1. Minus the curve on the left was my blue, the y plus 1. So this is in terms of y, so it's dy. From 0 to 1, the blue is on the left, so it's y plus 1 minus the red, y cubed plus 1. So you could go straight into antiderivative, but I would combine like terms first. So you get y cubed minus y, the positive and negative 1 cancel. This one you get y minus y cubed, positive and negative 1 cancel. So now antiderivative. Antiderivative of y cubed would be 1/4 y to the 4th. Minus antiderivative of y, 1/2 y squared. Negative 1 to 0. The other one's the same, just the signs are flipped. So 1/2 y squared minus 1/4 y to the 4th. From 0 to 1. If you put in 0, you get 0 minus, if you put in negative 1, you get 1/4 minus 1/2. Here, if you put in 1, you get 1/2 minus 1/4. Put in 0, you get 0. You get 1/4 plus 1/4. and 1/2.
How did that become like that?
So here, we have a negative 1/4 minus 1/2 is a negative 1/4 plus
Oh.
a positive 1/4. Other questions? Problem 13. So again, an area problem. Find the area of the region bounded by the graphs of y equals 3x plus 1, y equals 7, and the y-axis. So pictures can be very helpful here. Y equals 3x plus 1, what's that? Line. Y-intercept is 1, slope is 3, so up 3 over 1. What's y equals 7? So here's my y equals 7. And the y-axis is right there. So we are just looking for the area of this region.
I didn't realize that the y-axis was like this.
Oh.
I thought it was like telling me that it was one.
Oh, gotcha. That's if you're doing volumes and like rotating around it. So we need a starting and stopping point. We can do this one in terms of x. The y-axis is when x is 0, so we basically need to find the point where these two meet. So you need to know when 3x plus 1 is 7. So that's when x is 2. So we're going to go from 0 to 2. Since those are x values, we're doing it in terms of x, so that's top minus bottom. So the top is 7 minus the bottom is the 3x plus 1. And so in terms of x, so we put dx. We combine like terms. And we get 7 minus 3x minus 1, so 6 minus 3x. Antiderivative of 6 is 6x. Antiderivative of 3x is 3 halves x squared. Put in 2. You get 12 minus 6. You put in 0, you get 0. So final answer is just 6.
I know Josie's learning so much about calculus right now.
She is enjoying it. You can be Grant for the day. Alright, is that one okay? Pictures are helpful. Notice several of these said to sketch. So be prepared for me to ask you to draw a sketch on the test. Not because I really want to grade your artwork, but because the picture helps you visualize it, and you're less likely to make a mistake if you're drawing the picture.
She's gonna get up to school and it's supposed to like turn into a cat somehow.
I'm pretty sure several of
Is
these.
this the one where if you squint and hold it really far away, it turns into like a
Yes,
like a
yes,
goose?
that's exactly what it is.
Sometimes draw the graphs wrong, and it just makes her problem wrong.
So, sketch the solid obtained by rotating the region bounded by the curves. X equals 3 square root of y. X equals 0. Y equals 9. About the y-axis. If I'm going about the y-axis, what variable do you think we're doing everything in terms of?
Why?
Okay. So we know already we're going to integrate, and it's going to be a dy at the end. So everything has to be y. Okay, x equals 3 square root of y. That may be hard for you to graph, but we can get there. X equals 0. What's that?
Vertical line is 0.
X equals is a vertical line, so we're talking about right there. Y equals 9. What's that?
Horizontal line is 9.
Okay, so you know we're bounded by those to start with. If you're not sure about this, you can always make a T-chart. Let me plug in my numbers for Y. Can you put in negatives?
No.
No. Put in nice ones. If you put in 0, you get.
0.
You put in 1, you get.
3.
Put in 4,
6.
9.
9.
So we have 0, 0. 1, 6, 4, and it keeps going right, and we're getting 9, 9. So it's just like a part of a parabola. Okay, so we are taking the region bounded by all of this. That means I'm taking this little part. And if I start spinning that around the y-axis, what am I getting?
Half circle.
Yep, semicircle, a bowl-looking thing.
My spaces on this graph are long.
There's my bowl. All right. So if we're integrating with y, what's my lowest y value?
0.
And my highest? Okay. What's a cross section look like? If I slice my bowl, if I'm looking at it, so it's pi r squared. How do we get the radius of that?
It's the X.
Okay. So we're going to integrate from 0 to 9 if you want. You can even take your pi out. It's just a coefficient. This gives you 9. Square root of y squared is just y. So you could even say this is 9 pi times the integral from 0 to 9 if you wanted. You don't have to. Antiderivative of y would be 1/2 y squared, or 9 pi over 2 y squared. From 0 to 9. So 9 squared is 81, 0 squared is 0. 81 times 9 over 2. 729 pi over 2. So volume is when you do the pi r squares. We have more time. There any of these 15, 16, 17, those are some of our harder ones, so we want to look at one of those. I guess 17 is not horrible. 15, 16.
You think that would be fire?
There's one that I was struggling with, then I figured it out, and I didn't like write it down.
Are you
I
fine?
might have done it already, and I don't even
Were
know.
any of these hollows?
I hope so.
16.
16 was a washer.
Yeah, 16 is the washer method. Do you want to do that one? To refresh.
What type of cereal?
So, sketch the solid obtained by rotating a region
Interesting.
bounded by the curves. Y equals x squared. Y equals square root of x around the x-axis. If we're going around the x-axis, is my variable going to be x or y?
X.
X.
Sandal's not always coughing her lung out.
So y equals x squared, that's a parabola. The square root of x, remember, looks like this. So we're taking this little region, and when I rotate that around the axis, we're rotating that little hollowed out region. And so we are getting something like that. That is a horrible sketch. Pretend you know what that's
That
supposed
is
to be.
like the when you
Looks
flip
like a
it.
ring.
When you flip it,
Uh-huh.
the parabola piece is on top, right?
What?
The part.
The parabola is, on the
You flip
bottom
it?
side, yes.
Yes. Okay.
So we need to find these intersections. So if you square, that means x to the 4th is equal to x. Subtract over your x. Factor it out. So our intersections are 0 and 1. So that's where we're integrating from. X equals 0 to x equals 1. It's a washer So you have to do pi r squared minus pi r squared, or you could just take the pi out. And you have to do the 2 radius squareds. I'm doing in terms of x. So if we take this cross section, the outside one, that is my square root of x. So I have to do the square root of x squared. The inside is my parabola, so x squared. So that gives me x minus x to the 4th. So antiderivative. So antiderivative of x is 1/2 x squared. Minus 1/5 x to the 5th. We're looking from 0 to 1. Plug in 1. You get 1/2 minus 1/5. Put in 0, you get 0. And so that gives us 3.